Hello, in this lecture we will find out the values of line segments X and Y. In the drawing we have square DBEF that is inside the right triangle ABC. We know that DB equals to BF equals to EF equals to DE equals to 1. We also know that the hypotenuse of the right triangle ABC, the hypotenuse AC equals to 3 units. And we want to find out the values of line segment XC that equals to FC. And we also know we want to know the value of line segment Y that is actually equals to AD. Okay? So first of all, we know that the opposite sides of a square are parallel to each other. That is to say, DE is parallel to BF. DE is parallel to BF. According to the rule that the opposite sides of a square are parallel to each other, we will get that DE is parallel to BF in square DBEF. But we also know that BC is one side of the right triangle ABC. So BC is a side of a triangle. It is absolutely a straight line. So BC is a straight line. And BF is part of BC. BF is part of BC, and BF is parallel to DE. Therefore, BC, that is a straight line, must be also parallel to DE because of the fact that if a part of a straight line is parallel to other straight line, then the straight line itself must be also parallel to this straight line. So BF is parallel to DE, that is part of BC, therefore BC will be also parallel to DE. So we found out that BC is parallel to DE. Okay, we concluded that BC is parallel to DE, and we also have rule number 1. According to rule number 1, corresponding angles between parallel lines are equal to each other. Corresponding angles between parallel lines are equal to each other. So I read rule number 1 again. according to rule number 1, corresponding angles between parallel lines are equal to each other. And we actually can implement rule number 1 in our drawing because of the fact that those two angles are defined as corresponding angles, that is to say, angle D, angle AED and angle ECF are two corresponding angles, and those two corresponding angles are located between the parallel lines DE and BC, that is to say DE is parallel to BC according to what we have already found out. Therefore, they are equal to each other according to rule number 1. That is to say, we can write down that angle AED, this angle, is equal to this angle that is actually angle ECF, and they are equal to each other according to rule number 1. I repeat again, angle AED equals to angle ECF according to rule number 1, because of the fact that those two corresponding angles are located between the parallel lines DE and BC, they are equal to each other. So if we define angle AED, this angle is theta, then angle ECF will be also equal to theta. You can see it from this equation also. If angle AED equals to theta, then from this equation we can derive that angle ECF also equals to theta. So we found out that those two angles, they are both equal to theta. Therefore, actually, triangle. Okay, so in the next step, I will present to you a new rule number 2. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. I will write it down. The sum of the angles on one side of a straight line is equal to 180 degrees. So I read rule number 2 again. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. So here we know that side AB is one side of triangle ABC, therefore it is absolutely a straight line. So we can write down that AB is a straight line because of the fact that is one side of the triangle, the right triangle ABC. AB is a straight line. Okay, AB is a straight line. Therefore, according to rule number 2, if we focus on this side of the straight line AB at point D, then the sum of the angles must be equal to 180 degrees. So if we define angle ADE as x, then we get that x plus 90 degrees must be equal to 180 degrees according to rule number 2. Okay, x plus 90 degrees must be equal to 180 degrees according to rule number 2. Here we subtract 90 degrees from this equation and we get that angle x equals to 180 degrees minus 90 degrees. That is to say, angle x equals to 90 degrees. So we found out that angle x is a right angle. That is to say, it equals to 90 degrees. So we substitute angle x by a right angle. Therefore, we can say also that triangle ADE is a right triangle. Likewise, BC is one side of triangle ABC, therefore it is absolutely a straight line. So BC is a straight line. Okay, BC is a straight line, and again, if we focus on the upper side of the straight line BC at point F, then the sum of the angles must be equal to 180 degrees. So if we define angle EFC as angle Y, then we will get that y plus 90 degrees must be equal to 180 degrees. I'll write it down. The size of angle y plus 90 degrees. In total, they must be equal to 180 degrees according to rule number 2. So here we will subtract 90 degrees from this equation and we will get that angle y equals to 180 degrees minus 90 degrees is 90 degrees. So we found out that angle y is a right angle. That is to say, it equals to 90 degrees. So we substitute angle y by right angle. So actually it means that triangle FEC is a right triangle. So actually we have 3 right triangles. This is the first one, this is the second one, and triangle ABC is also a right triangle. So we will focus on the right triangle, triangle AED. On the right triangle, triangle AED, tangent theta equals to AD over DE. I will repeat again. In the right triangle, triangle AED, we know that tangent theta equals to AE over DE. Tangent theta equals to AD over DE. So, but AD equals to Y according to what is given us in the question, and DE equals to 1 because of the fact that all the sides of a square are equal to each other. DE also equals to 1 unit and FE also equals to 1 unit. So it is actually DE equals to 1. So in conclusion, we actually found out that according to equation number 1, tangent theta equals to Y. I'll repeat again. According to equation number 1, tangent theta equals to Y. In the next step, we focus on triangle ADE. In triangle EFC, on triangle EFC, we know that tangent theta equals to EF over FC. I'll repeat again. In the right triangle, triangle EFC, tangent theta equals to EF over FC. But EF equals to 1 and FC equals to X according to what is given in the question. So in conclusion, we get that according to equation number 2, tangent theta equals to 1 over X. Again, according to equation number 2, tangent theta equals to 1 over X. And we have two different expressions for tangent theta. We will create equation number 3 that states that tangent theta according to equation number 1 must be equal to tangent theta according to equation number 2. So again, equation number 3 states that tangent theta according to equation number 1 that equals to Y must be equal to tangent theta according to equation number 2 that equals to 1 over X. So actually we found out that according to equation number 3, Y equals to 1 over X. That is to say, Y is the inverse number of X. If we multiply equation number 1 by equation number 3 by X, we will get that X times Y equals to 1. When the multiplication of two numbers is equal to 1, it means that 1 is the inverse number of another. So we can write down that X is the inverse number of Y. And it is also true to say that Y is the inverse number of X. because either you can present equation number 3 that y equals to 1 over x, but you can also present equation number 3 that is x equals to 1 over y, because if you multiply the equation, if you divide this equation by x, you will get that y equals to 1 over x, and if you divide it by y, you will get that x equals to 1 over y. Okay? So, for example, if x equals to 5, then y must be equal to 1 over 5. And you can also say that 5 is the inverse numbers of 1 over 5, and 1 over 5 is the inverse numbers of 5. Why? Because the multiplication of the two numbers by each other will give us 1. So in the next step, we will focus on the right triangle ABC. On the right triangle ABC, according to the Pythagoras theorem, PT is the abbreviation for Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The square of the hypotenuse in the right triangle ABC is AC squared. And it must be equal to the sum of the squares of the perpendiculars, that is to say, it must be equal to AB squared plus BC squared. I will repeat again. In the right triangle ABC, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say, AC squared equals to AB squared plus BC squared. AC equals to 3 units. It is given us the question. Therefore, AC squared is 3 squared. 3 squared is 9. Equals to AB squared. AB equals to y plus 1, so AB squared will be equal to y plus 1 squared. Plus BC squared. BC equals to x plus 1, therefore BC squared will be equal to x plus 1 squared. So actually, in conclusion, we found out that according to equation number 4, 9 equals to y plus 1 squared plus x plus 1 squared. Here we will open the brackets on this side of equation number 4. We will get that y plus 1 squared, it is actually y squared plus 2y plus 1. And x plus 1 squared is x squared plus 2x plus 2 equals to 9. According to equation number 3, we've already found out that y equals to 1 over x. Y equals to 1 over x. Therefore, we can substitute y in equation number 4 by 1 over x. We will do it now, and we will get that according to equation number 4, y squared, y is 1 over x. So y squared will be equal to 1 over x squared plus 2y, that is to say it is 2 times 1 over x, plus 1 plus x squared plus 2x plus 2 equals to 9. Here we will organize the expressions and we'll get here that x squared plus 1 over x squared, 1 plus 1 is 2, I repeat again, 1 plus 1 is 2, so it is plus 2 plus 2x plus equals to 9. So we got here y squared plus 2y plus 1, this is to say 1 over x squared plus 'So we have here x squared plus 1 over x squared one over x squared plus 2 over x plus 1 plus x squared plus 1 plus 2x equals to 9. So here we have x squared plus 1 over x squared plus 2 according to equation number 4 equals to 2x plus 2 over x, that equals to 9. So here x squared plus 1 over x squared plus 2 is equal to x plus 1 over x squared and here we will take 2 as a common factor and we'll get it inside the brackets. We'll have x plus 1 over x. Here we'll subtract 9, so it equals to 0. Here we will substitute x plus 1 over x by t, that is to say we will define t is equals to x plus 1 over x, t equals to x plus 1 over x according to our definition. Therefore we'll get that equation number 4 will be equal to, here it is t squared plus 2t minus 9 equals to 0. So we got here a quadratic equation, and the general formula for a quadratic equation is actually ax squared plus bx plus c equals to 0. Here a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for, and we will find out the value of x according to a special formula for x. X is equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. In our specific expression, t squared plus 2t minus 9 equals to 0, the coefficients are as follows. A, first of all, the variable that we are looking for is t, so x equals to t. And we also know that a equals to 1, b equals to 2, and c equals to minus 9. So we'll put the data inside the equation for x, and we'll find out the value of t. X equals to t, so t equals to minus b. B is 2, so minus b is minus 2, plus minus square root of b squared. B is 2, b squared is 2 squared, 2 squared is 4, minus 4 times a times c. Minus 4 times a is 1, so minus 4 times 1 is minus 4, times c, it is minus 9, so it is minus 4 times minus 9 over 2a. A is 1, so 2 times 1 is 2. So in conclusion, we found out that t equals to minus 2 plus minus, here minus 4 times minus 9 is 36, and 36 plus 4 is 40, over 2. 40 is 4 times 10, and the square root of 4 is 2, so we get that 2 equals to minus 2 plus minus 2 times square root of 10 over 2. 2 over 2 is 1, and minus 2 over 2 is minus 1, so we get that 2 equals to minus 1 plus minus square root of 10. So here we have two possible solutions for t. The first solution is t equals to minus 1 plus square root of 10. And the second solution for t is t equals to minus 1 minus square root of 10. T, according to our definition, t equals to x plus 1 over x, and x is length, is the length of the side of the triangle, so therefore it must be a positive number. Therefore x is a positive number, and it must be equal to this expression that is minus 1 minus square root of 10, that is a negative number. and because of the fact that the positive number can never be equal to a negative number, that is to say, there is a contradiction. Therefore, this possibility is not correct. We will cancel this possibility, and we left only with the possibility that the value of t is minus 1 plus square root of 10. According to our definition, t equals to x plus 1 over x, and it equals to it equals to square root of 10 minus 1. Here we will multiply x by x, and then we will divide it by x in order to have a common factor with 1 over x, and we get that x squared plus 1 over x equals to square root of 10 minus 1. Here we will multiply this equation by x, and we will get that x squared plus 1 equals to square root of 10 minus 1 times x. Here we will subtract from this equation square root of 10 minus 1 times x, and we will get the quadratic equation that states that x squared minus square root of 10 minus 1 times x plus 1 equals to 0. So we got here a quadratic equation. In this quadratic equation, the coefficients are as follows. Here a equals to 1, b equals to minus square root of 10 minus 1, c equals to 1. And the formula for x, that is actually t, it is not t, but it is x. The solution for x is x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. So we'll put the data inside this equation for x, and we'll find out the value of x. And we'll get that x equals to minus b. We have here minus times minus is plus, so it is actually, we left only with square root of 10 minus 1. Plus minus square root of b squared. B equals to minus square root of 10 minus 1, so it is actually square root of 10 minus 1 squared. Minus 4 times a times c. A is 1, c is 1, so it is minus 4. All divided by 2. 2 times 1 is 2, so 2a is 2. So we get here that x equals to square root of 10 minus 1 plus minus here square root of 10 minus 1 squared is square root of 10 squared, that is 10, plus 1 minus 2 times square root of 10 minus 4, all divided by 2. So we found out actually that x equals to square root of 10 minus 1 plus minus, here we have 10 plus 1 is 11, 11 minus 4 is 7, so it is actually 7 minus 10 times square root of 10 all divided by 2. So first of all, we'll find out the value of 7 minus 10, 2 times square root of 10. What is the value of 7 minus 2 times square root of 10? The value of 7 minus 2 times square root of 10 is actually equals to 7 is 5 plus 2, so we'll substitute 7 by 5 plus 2 minus 2, and the square root of 10 is square root of 5 times square root of 2, so I'll write it down. We substitute square root of 10 by square root of 5 by times square root of 2. And it actually equals to, first of all, we know that 5 is the square root of 5 square. And we also know that 2 is the square root of 2 square minus 2 times square root of 5 times square root of 2. Actually, this expression, square root of 5 square plus square root of 2 square minus 2 times square root of 5 times square root of 2, is very similar to the algebraic identity that states that a square plus b square minus 2 times ab equals to a minus b square. And in our specific expression, a equals to square root of 5 and b equals to square root of 2. That is to say, we can substitute our expression by a minus b square when a equals to square root of 5 and b equals to square root of 2. And so we'll do it now. We will get that square root of 5, that is a, minus b, that is square root of 2 square, is equal to this expression. And indeed, if you open this expression, you will get to this expression. So those two expressions are equal to each other. So actually, we found out that 7 minus 2 times square root of 10 is equals to square root of 5 minus square root of 2 square. So we substitute 7 minus 2 times square root of 10 by square root of 5 minus square root of 2 square. So we'll do it now, and we'll get that x equals to square root of 10 minus 1 plus minus, and I repeat again, we substitute 7 minus 2 times square root of 10, that is inside the root, by square root of 5 minus square root of 2 square, all divided by 2. So here we have root and square. The square cancels the root, and we left only with square root of 5 minus square root of 2. So I write it down. We get that x equals to square root of 10 minus 1 plus minus, and here we will have square root of 5 minus square root of 10, because of the fact that the root and the square cancels each other. And we left only with this expression, all divided by 2. So we have here two solutions that are possible. We will call to the first solution for x, x1, and we will call to the second solution for x of this quadratic equation, x2. So x1 the first solution for x will be equal to square root of 10 minus 1 plus square root of 5 minus square root of 2, and the second solution for x will be defined as x2, and x2 will be equal to square root of 10 minus 1 plus minus, the second solution is minus square root of 5 minus square root of 10. So we'll continue with x1, and we'll get that x1 equals to, here we'll substitute square root of 10 by square root of 5 times square root of 2 minus 1 plus square root of 5 minus square root of 2, all divided by 2, of course. So here we take square root of 5 as a common factor, and we get that inside the brackets we will have square root of 2 plus 1 here we take minus 1 as a common factor. Inside the brackets we will have square root of 2 plus 1 all divided by 2. So here we take square root of 2 plus 1 as a common factor, and we get that x1 equals to square root of 2 plus 1 is a common factor, and inside the brackets we'll have square root of 5 minus 1 all divided by 2. So we found out that x1 equals to square root of 2 plus 1 times square root of 5 minus 1 over 2. We will do the same process for x2. x2 equals to square root of 10 minus 1 minus square root of 5 minus square root of 2 over 2. So x2 equals to square root of 10 minus 1 minus square root of 5. Minus and minus is plus, so it is plus square root of 2 over 2. Here we will substitute square root of 2 by square root of 5 times square root of 2 minus 1 minus square root of 5 plus square root of 2 over 2. So here we take square root of 5 as a common factor, and inside the brackets we will have here square root of 2 minus 1 plus square root of 2 minus 1 all divided by 2. So here we take square root of 2 minus 1 as a common factor out of this expression, and we get that square root of 2 minus 1 is a common factor. Inside the brackets here we will have square root of 5, and from this expression we will have 1. So it is square root of 5 plus 1 all divided by 2. So we found out that x2 equals to square root of 2 minus 1 times square root of 5 plus 1. In the next step, we will multiply square root of 2 by, we will multiply x1 by x2, and we will get that x2 times x1 will be equal first of all, I will write down again the values of x x1 and x2, we found out that x1 equals to square root of 2 plus 1 times square root of 5 minus 1 over 2. This is the value of x1. And the value of x2, it is actually equal to square root of 2 minus 1 times square root of 5 plus 1, all divided by 2. This is the value of x2. In the next step, we will multiply x1 by x2, and we will get that x1 times x2 equals to square root of 2 plus 1 times square root of 5 minus 1, all divided by 2. This is x1, we will multiply it by x2, and x2 is square root of 2 minus 1 times square root of 5 plus 1 over 2. Here we will organize the expressions in a different order, and we will get that x1 times x2 equals to square root of 2 plus 1 times square root of 2 minus 1, and we have also square root of 5 plus 1 times square root of 5 minus 1, all divided by 2 times 2, that is 4. So we have square root of 2 plus 1 times square root of 2 minus 1 times square root of 5 plus 1 times square root of 5 minus 1. We'll use the algebraic identity that states that a plus b times a minus b equals to a squared minus b squared. Okay, and square root of 2 plus 1 times square root of 2 minus 1, in this specific expression, a equals to square root of 2, b equals to 1, and we know that a plus b times a minus b equals to a squared minus b squared. So it will be equal to a squared, square root of 2 squared is 2, minus b squared. B is 1, so b squared is 1 squared, 1 squared is 1, so it is 2 minus 1. And we also have to multiply square root of 5 plus 1 by square root of 5 minus 1. In this specific expression, a equals to square root of 5 and b equals to 1. So a squared will be equal to square root of 5 squared. Square root of 5 squared is 5 minus b squared. B is 1, so b squared is 1 squared. 1 squared is 1, so it is minus 1, all divided by 4. This is the value of x1 times x2. So it is 2 minus 1 is 1, 4 minus 5 is 4, over 4. 1 times 4 is 4, 4 over 4 is 1. So we actually found out that x1 times x2 is equal to 1. What does it mean that x1 times x2 equals to 1? It means that x1 is the inverse number of x2, and also x2 is the inverse number of x1. Okay, this is what this means. x1 and x2 are two inverse numbers, inverse numbers, and according to equation number 3, we have already found out that x times y is also 1. It means that x is the inverse number of y and y is the inverse number of x. But here we have two different solutions for x. And if we put the values, if we substitute x by x1 and y by y1, we will get that x1 is the specific solution for x. x1 times y1 is equal to 1. And again, it means that y1 is the inverse number of x1 . But we have already found out that x2 is the inverse number of x1. Okay, so we actually found that y1 is the inverse number of x1, and we also found out that x2 is the inverse number of x1. That is to say, we will derive from those two sentences that y1 equals to x2. y1 equals to x2, and we also have from equation number 3, we know that x times y, according to equation number 3, equals to 1. So if we put the solution inside the equation number 3, the second solution is x2 and y2. So we will put the solution inside equation number 3, and we will get that x equals to x2, this is the solution, and y equals to y2. So x2 times y2 equals to 1 according to equation number 3. And it means that x2 times y2 equals to 1. It means that y2 is the inverse number of x2, but according to what we have already found, out that x2 is also the inverse number of x2. Okay, so we know that y2 is the inverse number of x2, and x2 is also the inverse number, and here y2 is the inverse number of x2, and we already found out that x1 is the inverse number of x2. So we know that y2 is the inverse number of x2, and x1 is also the inverse number of x2. From those two sentences, we will derive that y2 equals to x1. y2 equals to x1. So we actually found out in conclusion that y2 equals to x1 and y1 equals to x2. Therefore, the two solutions for x and y, the first solution is x1, y1. The first solution is x1, y1, and x1 equals to x1 is equal to square root of 2 plus 1 times square root of 5 minus 1 over 2. This is the value of x1. And y1, according to what we have already found out, that y1 equals to x2. So we can write here that y1 equals to x2, and x2, it is actually square root of 2 minus 1 times square root of 5 plus 1 over 2. This is the value of x2, and x2 equals to y1. Therefore, x1 and y1 are those two expressions, and the second solution is x2 and y2, and we know that x2 equals to square root of 2 minus 1 times square root of 5 plus 1 over 2. This is the value of x2, but we have already found out that y2, now we have to write down the value of y2, but according to what we have already found out, y2 equals to x1. So x1 equals to square root of 2 plus 1 times square root of 5 minus 1 over 2. Okay, so actually those are the two solutions to the question, x1 and y1, x2 and y2, when we have already found out that y1 equals to x2 and y2 equals to x1. Okay, thank you very much. Now I will summarize the lecture. Actually, we have here square DEFB. One side of the square is equal to 1 unit, and the square is inside the right triangle ABC. You know that the hypotenuse AC of the right triangle ABC equals to 3 units. And we want to find out the value of line segment FC that equals to X, and the value of line segment AD that equals to Y. So we know that the opposite sides of a square are parallel to each other. That is to say, DE is parallel to BF. DE is parallel to BF. And BC is one side of triangle ABC. Therefore, it is absolutely a straight line. BC is one side of a triangle. It must be a straight line. And BF is part of the straight line BC, and BF is parallel to DE. So if part of the straight line BC is parallel to DE, then the straight line itself BC will be also parallel to DE. Okay? I repeat again. If part of a straight line is parallel to another straight line, then the straight line itself must be also parallel to that straight line. Therefore, we conclude that BC also parallel to DE. Then we have rule number 1. According to rule number 1, corresponding angles between parallel lines are equal to each other. So here we can implement rule number 1 in our drawing, because in our drawing we have those two angles are defined as corresponding angles, and they are located between the parallel lines DE and BC. Therefore, they are equal to each other according to rule number 1. Okay, so angle AED equals to angle ECF according to rule number 1. And if we define angle AED as theta, then from this equation we will derive that angle ECF also equal to theta. So we found out that those two angles are equal to each other and they are both equal to theta. Then I presented to you rule number 2. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. And here AB is one side of triangle ABC, therefore it must be a straight line. AB is a straight line. AB is a straight line. If we focus on this side of the straight line AB at point D, the sum of the angles must be equal to 180 degrees. So which angles we have at this side at point D? We have here 90 degrees plus this angle, that is angle X. We defined it as angle X must be equal to 180 degrees. Angle X plus 90 degrees must be equal to 180 degrees according to rule number 2. We subtracted 90 degrees from this equation and we found that angle X equals to 90 degrees. So angle X is equal to 90 degrees. Therefore, triangle ADE is a right triangle. Likewise, we know that BC is one side of the right triangle, triangle ABC. Therefore, it is absolutely a straight line. BC is a straight line. So if we focus on the upper side of the straight line BC at point F, then the sum of the angles must be equal to 180 degrees. So if we define this angle as Y plus this angle that equals to 90 degrees, in total the sum of those two angles must be equal to 180 degrees. Angle Y plus 90 degrees equals to 180 degrees. We will subtract 90 degrees from this equation and we will get that 180 degrees minus 90 degrees equals to 90 degrees. That is to say, angle Y equals to 90 degrees. So this angle is a right angle. Therefore, triangle EFC is a right triangle. Then we focus on the right triangle, triangle ADE. In this right triangle, triangle ADE, we know that tangle theta equals to AD over DE. Tangle theta equals to AD over DE. But AD equals to Y according to what is given us the question. DE equals to 1. So in conclusion, we found out that in triangle AC, ED times theta equals to y. Then we focus on the right triangle, triangle EFC. Here, tangent theta equals to EF over FC. Tangent theta equals to EF over FC. EF equals to 1. FC equals to x according to what is given us in the question. So in conclusion, we found out that according to equation number 2, triangle EFC, tangent theta equals to 1 over x. Then we created equation number 3 that states that tangent theta according to equation number 1 must be equal to tangent theta according to equation number 2. Tangent theta according to equation number 1 is y, and it must be equal to tangent theta according to equation number 2, that is 1 over x. So in conclusion, we found out that according to equation number 3, y equals to 1 over x. What does it mean? It means that y is the inverse number of x, and also x is the inverse number of y, because if we multiply equation number 3 by x and then we divide it by y, we get that x equals to 1 over y. So each is the inverse number of the other, each one. So if we multiply equation number 3 by x, we will get that x times y equals to 1. Again, when the multiplication of two numbers by each other equals to 1, it means that each one is the inverse number of the other. Okay, so we derive that from equation number 3, we derive that x is the inverse number of y and y is the inverse number of x. Okay, then according to equation number 3, y equals to 1 over x. So why? Because from equation number 3, xy equals to 1, we can derive that if we divide the equation number 3 by x, we will get that y equals to 1 over x. And if we divide the equation number 3 by y, we will get that x equals to 1 over y. It means that the two numbers are the inverse number of each other. And in the next step, we focus on the right triangle, triangle ABC. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is AC, so the square of the hypotenuse is AC square, and AC square equals to AB square plus BC square. AC equals to 3. It is given us in the question. So AC square is 3 square. 3 square is 9. And it equals to AB square. AB is y plus 1. AB square is y plus 1 square. BC is x plus 1, so BC square is x plus 1 square. So in conclusion, we found out that according to equation number 4, 9 equals to y plus 1 square plus x plus 1 square. Here we open the brackets on this side of equation number 4, and we got that y plus 1 square is y square plus 2y plus 1 plus x plus 1 square is x square plus 2x plus 1, and that equals to 9. Then according to equation number 3, y equals to 1 over x. It means that we can substitute y by 1 over x. We did it, and we got it according to equation number 4. Y square is 1 over x square, plus 2y is 2 over x, plus 1 plus x square plus 2x minus 9 minus here it is actually plus 1 equals to 9. Here we organize the expressions in a different order, and here we have x square plus 1 over x square plus 2 plus 2x equals to 9. And we know that x square plus 1 over x square plus 2 is x plus 1 over x square. And here we took 2 as a common factor, and inside the brackets we left with x plus 1 over x minus 9 equals to 0. We defined t as x plus 1x. That is to say, t equals to x plus 1x. And according to our definition, we can substitute t by x plus 1x. We did it and we got that equation number 4, it is actually equals to t squared plus 2t minus 9. So here we have a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. Here a, b and c are the coefficients of the quadratic equation, and x is the variable that we are looking for, and we find out the value of x according to a special formula. X equals to minus b plus minus square root of b squared minus 4ac over 2a. A, b and c are the coefficients of the quadratic equation, and x is the variable that we will find out according to this equation. In our specific expression, the variable that we are looking for is t, so x equals to t, a equals to 1, b equals to 2, and c equals to minus 9. So we'll put the data inside this formula in order to find out the value of t, because x equals to t. So t equals to minus b, b equals to 2, so minus b is minus 2, plus minus square root of b squared. b is 2, b squared is 2 squared, 2 squared is 4, minus 4 times ac. 4 times a is 1, 4 times 1 is 4, times c is minus 9. So actually we have minus 4 times minus 9, that is 36, and 4 plus 36 is 40, all divided by 2. So here we have t equals to square root of 40 over 2, but 40 is 10, 4 times 10, and the square root of 4 is 2, so in conclusion we got that t equals to minus 2 plus minus 2 times square root of 10 over 2. Okay, minus 2 over 2 is minus 1, and 2 over 2 is 1, so in conclusion we got that t equals to minus 1 plus minus square root of 10. It means that t has two solutions that are possible. The first solution is t equals to minus 1 plus square root of 10, and the second solution is t equals to minus 1 minus square root of 10. But t, according to our definition, equals to x plus 1 over x, and x is length. X is length, therefore x plus 1 over x must be a positive number, while minus 1 minus square root of 10 is a negative number. And a positive number can never be equal to a negative number, therefore this solution is not correct. We cancel this solution and we left only with the solution that equals to minus 1 plus square root of 10. Okay? But what is the value of t? T, according to our definition, equals to x plus 1 over x. That equals to square root of 10 minus 1. Here we multiplied x by x and then we divided by x in order to overcome a factor with 1 over x. And we got that x squared plus 1 over x equals to square root of 10 minus 1. We multiplied this expression by x and we got that x squared plus 1 equals to square root of 10 minus 1 times x. We subtracted from this equation square root of 10 minus 1 times x, and we got the quadratic equation that states that x squared minus square root of 10 minus 1 times x plus 1 equals to 0. Here, the coefficients of this quadratic equation are as follows: a equals to 1, b equals to minus square root of 10 minus 1, and c equals to 1, and the general formula for solving the quadratic equation is x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific expression, x equals to minus b, and minus is plus, so here minus b is actually square root of 10 minus 1, plus minus b squared. B squared is square root of 10 minus 1 squared, minus 4 times ac. A is 1, c is 1, so minus 4 times AC is minus 4, all divided by 2. Because 2a is 2, because of the fact that a equals to 1. So 2 times 1 is 2. So here we have x equals to square root of 10 minus 1 plus minus. Square root of 10 minus 1 square is square root of 10 square is 10, plus 1 square is 1, minus 2 times square root of 10 times 1. So it is actually 10 plus 1 minus 2 times square root of 10 minus 4. 10 plus 1 is 11. 11 minus 4 is 7. So in conclusion, we found out that x equals to square root of 10 minus 1 plus minus 7 minus 2 times square root of 10 over 2. Then we took the expression inside the root, that is 7 minus 2 times square root of 10, and we actually change it here. The expression inside the root is 7 minus 2 times square root of 10. 7 is 5 plus 2, so we substituted 7 by 5 plus 2, and 2 times square root of 2 is square root of 5 times square root of 2, so we substituted square root of 10 by square root of 5 times square root of 2. Again, square root of 10 is square root of 5 times square root of 2, so we substituted square root of 10 by square root of 5 by square root of 2, and we got that 7 minus 2 times square root of 10 equals to 5 plus 2 minus 2 times square root of 5 times 2 times minus 2 times square root of 5 times 2 times square root of 2. We know that 5 is the square root of 5 square and 2 is square root of 2 square, minus 2 times square root of 5 times square root of 2. This expression is very similar to the algebraic identity that states that a square plus b square minus 2 times ab equals to a minus b square. It means that we can substitute this expression by a minus b square when a equals to square root of 5 and b equals to square root of 2, so a minus b square will be equal to square root of 5 minus square root of 2 square. So we can substitute 7 minus 2 times square root of 10 by square root of 5 minus square root of 2 square. We did it, and we got that x equals to square root of 10 minus 1 plus minus. Again, we substituted 7 minus 2 times square root of 10 by square root of 5 minus square root of 2 square, all divided by 2. Here the square cancels the root, and we left only with square root of 5 minus square root of 2, so in conclusion we got that x equals to square root of 10 minus 1 plus minus square root of 5 minus square root of 2 over 2. And here we have two solutions that are possible because it is plus minus. The first solution, we define the first solution as x1, and the second solution is x2. The first solution, x1, equals to square root of 10 minus 1 plus square root of 5 minus square root of 2 over 2, and the second solution, x2, is square root of 10 minus 1 minus square root of 5 minus square root of 2. So the first solution, x1, we substituted square root of 10 by square root of 5 times square root of 2, and then we got that x1 equals to square root of 5 times square root of 2 minus 1 plus square root of 5 minus square root of 2 over 2. Then we took square root of 5 as a common factor of this expression, and we got that x1 equals to square root of 5, and inside the brackets we have square root of 2 plus 1 minus square root of 2 plus 1. Here we took square root of 2 plus 1 as a common factor from this expression, and we got that x1 equals to square root of 1 plus square root of 2 plus 1 is a common factor. The second is a common factor, and inside the brackets we left only with square root of 5 minus 1 over 2. So in conclusion, we found out that the second solution to the quadratic equation is x1, that equals to square root of 2 plus 1 times square root of 5 minus 1 over 2. And the second solution to the quadratic equation is x2, that equals to square root of 10 minus 1 minus square root of 5 minus square root of 2 over 2. So x2 equals to square root of 10 minus 1 minus square root of 5 minus and minus is plus, so it is plus square root of 2 over 2. Then we substituted square root of 10 by square root of 5 times square root of 2, and we got that x2 equals to square root of 5 times square root of 2 minus 1 times square root of 5 plus square root of 2 over 2. Here we took square root of 5 a common factor, and we got that x2 equals to square root of 2 is a common factor. Inside the brackets we have square root of 2 minus 1 plus square root of 2 minus 1. Here we took square root of 2 minus 1 as a common factor, and we got that x2 equals to square root of 2 minus 1 is a common factor, and inside the brackets we have square root of 5 plus 1 over 2. So x2 in conclusion is equal to square root of 5 minus 1, square root of 2 minus 1 times square root of 5 plus 1 over 2. And x1 equals to square root of 2 plus 1 times square root of 5 minus 1 over 2. Then we multiplied x1 by x2. Again, this is the value of x1, this is the value of x2, and we multiplied x1 by x2, and this is x1 times x2, and we organized differently the expressions, and we got that x2 times x1 equals to square root of 2 plus 1 times square root of 2 minus 1 times square root of 5 plus 1 times square root of 5 minus 1, and 2 times 2 is 4. And then here we used the algebraic identity that states that a plus b times a minus b equals to a squared minus b squared, in order to calculate the value of the expression square root of 2 plus 1 times square root of 2 minus 1. Here a equals to square root of 2 and b equals to 1. And we know that a plus b times a minus b equals to a squared minus b squared. So a squared is square root of 2 squared is 2 minus b squared. B is 1. B squared is 1 squared. 1 squared is 1. So it is 2 minus 1. And then the expression square root of 5 plus 1 times square root of 5 minus 1 will be equal to, here we know that a equals to square root of 5, b equals to 1. So a squared is square root of 5 squared, that is 5, and b squared is 1 squared, 1 squared is 1, so it is 5 minus 1. So x1 times x2 equals to 2 minus 1, that is 1, times 5 minus 1, that is 4, over 4. 1 times 4 is 4. 4 over 4 is 1. So we found out that x2 times x1 times x2 equals to 1. What does it mean? It means that because of the fact that x1 times x2 equals to 1, it means that x1 is the inverse number of x2, and x2 is the inverse number of x1. But according to equation number 3, we have already found out that xy is also equals to 1. What does it mean? It means that x is the inverse number of y, and y is the inverse number of x. So if we put the solutions inside the question number 3, we will get that x1 times x1, x1 times y1, x1 is x equals to x1, and y equals to y1, so we'll get that x1 times y1 equals to 1. Because of the fact that x1 times y1 equals to 1, it means that y1 is the inverse number of x1. But we have already found out that x2 is the inverse number of x1. So because of the fact that y1 and x2 are both the inverse number of x1, we will derive from this that y1 equals to x2. Likewise, if we put the second solution inside the question number 3, the second solution for x is x2, and for y is y2, so x2 times y2 will be equal to 1. What does it mean? The minimum of x2 times y2 equals to 1. It means that y2 is the inverse number of x2 from one side. But we have already found out that x1 is the inverse number of x2. So because of the fact that y2 and x1 are both the inverse number of x2, we will derive from this that y2 equals to x1. So in conclusion, we found out that y2 equals to x1 and y1 equals to x2. Therefore, the solution for our question, we have two solutions, x1 and y1, and the second solution is x2 and y2. We have already found out that x1 equals to square root of 2 plus 1 times square root of 5 minus 1 over 2, and y1 equals to x2. So this is actually, the expression is x2. And the second solution is x2 and y2. This is the expression for x2, and y2, according to this equation, y2 equals to x1. So this expression, it is actually x1. So this is x1, y1, this is the first solution, and the second solution, x2, y2, is this solution. Okay? That is the answer to the questions. Thank you very much.